Hello and welcome to my presentation on enthalpy for OCR F322. Enthalpy is the heat content that is stored in a chemical system. An endothermic reaction is a reaction where there is heat loss in a chemical system. An example of an endothermic reaction is the oxidation of fuels and self-heating cans. An endothermic reaction is a reaction where there is a heat gain in a chemical system. An example of an endothermic reaction is photosynthesis and self-cooling beer cans. The following is the enthalpy profile diagram for an endothermic reaction. The blue line represents the activation energy without a catalyst, and the red line represents the activation energy with a catalyst. As you can see, the catalyst lowers the activation energy because it provides an alternative pathway. Also, the reactants have a higher energy than the product, and the difference in energy, or the delta H, is the arrow that points down between the reactants and the products. The following is an enthalpy profile diagram for an endothermic reaction. As you can see, the reactants have a lower energy than the products, and if a catalyst was used, then the activation energy would be lowered, and the delta H is upward pointing arrow between the reactants and the products. Standard enthalpy changes. The standard conditions that are used are 100 kPa minus 298 K and 1 molar. The definitions of a couple of different standard enthalpy changes are, so for reaction, is when the number of moles as specified in the balanced equation react together. For formation, it's when a mole of a compound is formed from its constituent elements, and for combustion, it's when 1 mole of a fuel completely burns in oxygen. When you're writing the equation for the enthalpy change or formation, you need to make sure that the product only has 1 mole, and for combustion, it'll always be a negative value. Other important information that you ask in exams, they ask you why there's a big difference between the experimental value and the theoretical value, and this is because there could have been heat loss to the surroundings and the conditions were non-standard. The bond enthalpy is the enthalpy change that takes place when breaking by Holmley situation 1 mole of a given bond. Bond breaking is endothermic and bond making is exothermic. So in an exothermic reaction, you say that bond making is exothermic and bond breaking is endothermic, and more energy was released than absorbed. For an endothermic reaction, you again state that the bond breaking is endothermic and bond making is exothermic, and you say that more energy was absorbed than released. Thank you for watching.